Hi, today we're going to talk about the t-test. We have different kinds of t-tests to apply the analysis under different conditions. So if we know that the population variance between two populations are equal, but we don't know about the exact number, then we can apply this formula to calculate the t-score. And here is the formula for standard deviation for the pool variance. And then this is the confidence interval. I'm going to compile this file into a PDF, and then I'll just put it under the description, and then you can see it from there. And in the second condition, if the variance of the two populations, they are not equal, and then we don't know the exact number for the variance, then we're going to use a different formula to calculate the t-score, the degree of freedom, and the confidence interval. So here in our first examples, since in these examples we are given the population variance, which means that the population variance are not unknown, so that we are able to use the z-score to calculate for our analysis. First of all, we're going to draw a random sample from the population, and then we're going to apply for the formula. We can see that the z-score for our samples is 1.34, but the z-score for the rejection region is 1.96, which is greater than our z-score calculated for the sample, so that we do not reject the null hypothesis, which means there isn't a difference between the two populations. We can also check the p-value, which is 0.017, greater than 0.05. So again, we reject the null, which means there isn't a difference between M1 and M2. So again, we can also calculate the confidence interval. We can see that the lower bound is negative and the upper bound is positive. So since the interval contains 0, again, we confirm that there's no difference between the two population mean. So here, in the second examples, here we don't know the population variance, so we are going to use the t-table, the t-distribution. First of all, we're going to check if the assumption for the t-test is valid or not. So we're going to check if the samples follow a normal distribution. Since all the data points is very close to the QQ line, we can say that the difference follows a normal distribution. That's why we can apply t-test for our analysis. And then we're also going to check if the variance, since the p-value is greater than 0.05, we do not reject the null hypothesis. Here the alternative is that the variance ratio is not equal. So we do not reject the null, which means that the variance are equal. So we are going to use the first formula here to calculate for our analysis. So we can see that here we are going to use the R command to calculate for our t-test. Here we are going to use the two-sided test, and then we define our confidence interval as 0.95, and then the variance are equal. And then we can see that the p-value for this t-test is greater than 0.05. So we do not reject the null hypothesis, which means there isn't a difference between the two population mean. And also, we can also see that the confidence interval, the lower bound is negative and the upper bound is positive, which contains 0, so there's no difference between the population means. Here, in our next examples, we are going to apply the same procedure, and then we are going to check the assumption, which the difference follows the normal distribution, and then we're also going to check for the variance. The p-value is greater than 0.05, so we do not reject the null, which means there isn't a difference there isn't a difference between the two uh, the between the two variants. And here we are going to apply the t-test. Here we are going to check if the mean for the first population is greater than the mean of the second population. And then the confidence interval is again 0.05, and then uh, we set the variance equal to true. Here we have the p-value is 0.36, which is greater than 0.05 again. So we do not reject the null, which means there isn't a difference between the two populations here, F1 and F2. Here we are going to use a different approach to verify the normality assumption. Here we are using the QQ plot, but here we are going to use a different test, the normality test for the assumption. We can see that the p-value is greater than 0.05, so we do not reject the null that the distribution follows the normal distribution. So we have two methods to verify the normality assumption. So in the next examples, we are going to use the mathematical ways to calculate the t-scores, which is we're going to apply the formulas here. So we're going to do it the manual way to check the t-score. So again, we're going to draw random samples from our population, and then we're going to calculate the t-score, which is 0.8 approximately, and then the t-score for the rejection region is 2.1, which is greater than our t-score. So we do not reject the null hypothesis, which means there isn't a difference between the two populations, M1 and M2. Note that our degree of freedoms for the pole variance is simply n1 plus n2 minus 2, so it should be 18 here. And then we can also check for the p-value, which is 0.43 greater than 0.05, so reject the null. And then we can also use the R command to verify if our mathematical calculation is correct or not. So we also have 0.43 here. So our formula is correct, as well as our t-test here. We do not reject null since it is greater than 0.05. And also we can see that the confidence interval here contains 0. So we are also going to calculate manually to see, yeah, the lower bound is negative and the upper bound is positive. So we do not reject the null, same as here. And for our last examples here, we have population variance that are not equal. So we are going to apply the second formula here to do our t-test. So here we're going to run the variance test, which is less than 0.05. So we are going to reject the null, which we here. So which means that the variance ratio are not equal to 1. Simply means that the variance are not equal. So we set the t-test here equal to false. But we are also going to apply for the two-sided t-test, and the confidence interval is 0.95. So here we can see that the p-value is greater than 0.05. So we do not reject the null, which means that there isn't a difference again between our two populations here. So here are all our examples for the t-test under different conditions. And I'm going to compile this file and then put it online so that you can see the PDF file. And then I'll just provide all the examples as well in the PDF file. So thanks for watching, and let me know if you have any questions, and feel free to comment in the comment section. So thank you very much.